take a look here. We see 4 terms, which usually leads us to the grouping method. We don't see anything common to all 4 terms as a GCF that can be divided out. If I were to split it right down the center here, there's nothing in common within the first 2 terms, nor is there anything in common within the last 2 terms. So before we give up, we're going to try rearranging things. I notice the third term and the first term both have C's in them. So I'm going to move that third term to become the second term and see what I can do. This gives me 2C plus AC plus 3AY plus 6Y coming down. Now I'm going to split this baby down the middle because I see that there's a common factor of C within the first 2 terms. Dividing it out leaves me 2 plus A. And then in the second half of the problem, 3 and 6 both can be divided by 3, and at no extra charge, a Y can be divided out also, and we're left with A plus 2. Now, what we see in each half of the problem, the 2 plus A and the A plus 2 do not appear to be the same, but we know from the commutative property of multiplication that they are. So I am going to factor them out as if they were the same, and I'm going to choose to write them in the A plus 2 order because I prefer my variable at the start of the parentheses. So A plus 2 is divided out. First half of the parentheses I'm left with C. Second half of the problem I'm left with 3Y. And there we have an answer that looks very much like the answers to the previous problems we've been dealing with. Okay, a couple more problems here. Problem number 11 again has 4 terms. I note that the 6x and the 8x can be added together, but I'm not going to do so yet because we're going to learn how to do something with that a little bit later. Right now we're focusing on the grouping method. But I also notice that 12, 6, 8, and 4 are all even. So I'm going to divide the 2 out front. I'm actually going to use a bracket here because I know it's coming a little bit down the road, leaving me 6x squared plus 3x plus 4x plus 2. Still 4 terms. Then I'm going to split it down the middle and break down what's left, leaving the 2 out front. From the first 2 terms I can divide out the 3x. Dividing the 3x out of the 6x squared leaves me 2x. Dividing the 3x out of the 3x leaves me 1. Notice if I were subtracting or taking it away, there'd be nothing. And I need that 1 there as a placeholder so I can distribute and recreate the line above. In the second half of this problem, I can divide out a 2, leaving me again the 2x plus 1. And now you see what I'm seeing here. A 2x plus 1 common to each half of the problem can still be factored out. I have my 2 way out front, this 2x plus 1 being divided out, and when I divide it out I'm left with 3x and plus 2. And so there we have a more complicated expression, yet fully factored. Okay, the last problem for this short video. Again, I'm going to ask that question, can I take out a GCF? And 2 divides into all 4 of these terms. Dividing it out, I have 3f squared k plus 15k plus f squared plus 5. And I'm going to do what I did on the last problem. Split this baby down the middle. Note that I can factor out a 3 and a k from the first 2 terms, leaving me f squared plus 5. And over in the second half there is no GCF, but the f squared plus 5 looks very familiar. So I'm just going to divide a 1 out as a placeholder so that I can have the pattern that I've been working with. And that will enable me to now factor this f squared plus 5 out of each half of the problem. I have 2 out front, the f squared plus 5, which we just said was going to factor out, and then after I divide that out we have 3k at the first part of the problem and plus 1 in the second part of this problem. So there you go, the grouping method of factoring.